Discrete structures, relations, part 1. What is relation? Relation is a way to connect elements from one set to element of another set. Representation of relation. The first one, set. The second one, matrix. And the third one, digraph. Set is a relation between two sets where its value was determined by a condition that all elements in that relation must fulfill the condition. If A, B is an element of R, then A relates to B through R, and we can symbolize it as ARB. A, 5, 6, 7, and set B, A, B. And the solution is ARB equals to 5A, 6B, and 7A. And this is a relation from A to B. The next one, matrix. The relation R can be represented by matrix. For example, set A, 5, 6, 7, and B, A, B. Let R be a relation. The subset that exists in the relation above is being represented by number 1, and the one that isn't is being represented by number 0. And the next one, digraph. Digraph is a direct graph of R using vertex that represent each element and path that represent edge. For example, set A, STUV, and set R, ST, TS, SS, TT, TV, TU, UV, and VS. The solution to the example above is S relates to T, T relates to S relates to itself, T relates to itself, T relates to V, T relates to U relates to V, and V relates to S. Exercise. Given set A equals to 1, 2, 3, 4, relation R on A is defined as R 1, 2, 2, 3, 2, 4, 3, 4, and 4, 1. The matrix shown is a 4 times 4 binary matrix solution to a given problem. Each one represents a specific connection or condition that is satisfied from the relation, while each 0 indicates the absence of such condition. The notations on the side seem to indicate the relations or pairs of elements that correspond to the matrix structure. We can use the subset from the relation above to draw the digraph. The solution is 1 relates to 2, 2 relates to 3, 2 relates to 4, 3 relates to 4, and 4 relates to 1.
Domain and range. When there is a relation from A to B, we can find domain and range for relation R. A related to B. So let's start with the domain. First, element in set A. The domain consists of all elements that are part of the set A. This means that if an element is in the domain, it must belong to set A. 2. Mathematically, this is represented as domain relation subset A, which means that the domain of the relation R is a subset of A. Every element in the domain is taken from set A. Lastly, set of all first elements in the pairs. In a relation, we typically have pairs of elements like A and B. The domain is a set of all first elements from each of these pairs. So, if we have pairs like A1 and B1, A2 and B2, and so on, the domain will include A1 and A2 and so forth. Now, let's move on to the range. First, element in set B. The range consists of all elements that are part of set B. This means that if an element is in the range, it must belong to set B. Second, similar to the domain, this is represented mathematically as shown, which means that the range of the relation R is a subset of B. every element in the range is taken from set B. Lastly, set of all second elements in the pairs. The range is the set of all second elements from each pair in the relation. For example, if you have pairs like A1 and B1, A2 and B2, the range will include B1 and B2 and so on. Let's take a look at the example shown. So this explanation ties directly to the example we have shown earlier. So for the next slide title is the degree of a vertex. The degree of a vertex can be classified into two types. Firstly, in degree refers to the number of arrows pointing into a vertex. It represented by the second element in a set. To find it in a matrix, count the total number of 1 in a column. The second degree, it will be the out degree. This refers to the number of arrows going out from a vertex. It's represented by the first element in a set. To find it in a matrix, count the total number of 1 in a row. So as you guys can see here, this is the type of question that will be asked for this topic. If you wonder what is MR, MR is matrix of relations. And this is the proposed solution, providing a well-considered approach to addressing the issue at hand. Here is one of the exercise that you might find beneficial to try out. Let's start by finding the domain and range. The domain is the set of all first elements in the pairs 1, 2, 3, and 4. Meanwhile, the range is the set of all second elements 2, 3, and 4. Next, let's find the in degree and out degree for each element. First one, out degree is 1, in degree is 0. Second one, out degree is 1, in degree is 1. Third, out degree is 1, in degree is 3. Fourth, out degree is 2, in degree is 1. Now we have reached the topic path in relation. Here we skedaddle. Let's say we have a relation R on a set A. A path of length n in R from element A to element B is defined as a finite sequence that starts at A and ends at B. This sequence can be represented as shown in the slide. Notice that if the path has a length of n, it involves into n plus 1 elements, including both the starting point A and the end point B. Let's take a look at this example, mate. Here we go. This is the solution for the example that has been shown earlier. Reachability is our last final destination here, which is it is a concept in which there is a relation between x and y in whatever length possible. Here we skibidi. As usual, let's take a good look at this example and the solution. Let's take a closer look at the exercise, shall we? The solution for the path of length 2 is as follows. Meanwhile, the result for the path of length 3 is as shown. We have reached the final destination. There we land. Thank you for watching this video.